thought it was. It was using names, you know, like be careful. But
It will get better. You ready?
yeah. Alright, I've burned enough of your time. Sorry, those of you who don't even play sports.
Hey, he plays tennis. Our bag plays tennis.
Yeah, all that.
Well, let's clarify. Your bag is on the tennis team. But
Hey, when we're both 50, I wonder if you'll be playing basketball.
Oh! Jabber!
Hey, you know
tennis
what?
isn't gonna be a
You know what?
team.
My grandpa is over 70 and he's still playing basketball. So
Dad's playing on a team. He doesn't go to basketball.
You don't play on a tennis
he
team
does.
50?
He does?
Yeah.
Dang.
Remember, whenever you say
Such a
here,
not
we'll be
true.
telling you to do for it.
Such a not true.
Man.
That's an ab.
No, I'm a complete advocate for tennis. I love playing tennis. I don't really enjoy like playing basketball.
I want to get good at it because when I'm older, I can still play it.
Yeah, that is fun.
You don't like Grayson, but I'm
Grayson, do you think you'll switch over to pickleball? Or
No, I won't. It's close. No. I will when my knees get
I'll cook you a while later.
That will never happen.
Oh.
Grayson, remember your being recorded.
Okay. Whatever you say can and will be used against you. Okay, absolute value of x is equal to 7. What do we know x can equal?
Negative 7 or 7.
Okay? And then what do we know the graph looks like?
Do not.
Okay. That's easy.
Yeah.
Ish. The other parts aren't necessarily hard, we just make them hard. So absolute value of 6, okay? How do we rewrite this without absolute value? Let's start with this. We know absolute value is less than 6, so let's say, hey, it's less than 6, that's great. But can we keep trajectories all the way to the left? If we say like open circle at 6, and then we just go, oh yeah.
No.
No. Not an or.
An and.
There's
Wait.
an and.
Rainbow between 6 and negative 6. Sorry.
Right, and so we say rainbow, double, double rainbow.
Oh, yeah.
Okay, so we take whatever this is, and we make it x is less than 6, and then we tack on greater than the opposite of 6, greater than negative 6. You can mentally work through that and say, sure, if x is negative 8, the absolute value of negative 8 is 8, 8 is not less than 6. Okay, let's do a different one where absolute value is greater than 10. Okay, this is the or, where x is greater than 10. That's awesome. So we say 10 is here, open circle, going to the right. And then we say, yeah, I'm done. No, nay, nay, donkey breath, right?
What? Whoa.
As my professor always used to say, somebody didn't give me the wrong answer. Yeah, Dr. Poussin, he was a character, and he'd say, you answered incorrect, he'd just say, nay, nay, donkey breath. I don't know why. Maybe nay, nay is like a horse.
No, Nate, I don't think donkeys.
Yeah, but like, nay, nay.
Donkey breath.
Is that what he said? He said it like that?
Yeah, he just said, nay, nay, donkey breath.
No,
But then he
no.
would say, if you got it right, he'd say, throw that man a fish. Like a seal.
You should start doing that.
Yes, please
This
do
is so
that.
awesome. He was great.
Throw that man a fish.
Well, I would, but nobody gets anything right in here, so.
Cool wall.
Grayson got a couple of quotes today, or one quote today.
I got it.
You got a
What? What was it?
You can read it. It's up there with the other two. Grayson's going nuts.
I know.
We were talking about a former student I said, oh yeah, he was smarter than me. And Grayson goes, wow, he must have been smart. Actually, that's not very smart. So, okay. There we
Grayson is
go.
just savage.
So we know on the other side is all the values less than negative 10 actually work as well. So if you plug in like a negative 12, absolute value of negative 12 is 12. So 12 is greater than 10. Now, if it was just like that, it would be pretty straightforward and I would say relatively easy. If it's a little more challenging, just that we have to include some things like this. So we're going to say solve is that you're going to have, let's say, let's go with, we'll call this number 1, 3 times x plus 4. Actually, let's do this, minus 4 equals, whatever, pick an easy one, 12. The issue here is that we don't just have x equals, we have a 3 and then an x minus 4. So a couple errors occur. One error, for starters, don't distribute into absolute value. You can certain times, you can't other times. So it's easier just to say don't do it. Okay? Then the other error occurs is that people just drop the absolute value and say plus or minus 12. You don't want to do that. What you need to do is you need to isolate the absolute value, then do the plus or minus of the other side. So we would isolate the absolute value by dealing with the 3. This is 3 times. So then we say x minus 4 is equal to 4. Then the other error people make is they say absolute value, this must be x what? Plus 4. Some people do that. So what we do though is we take whatever's in here, don't change it. We say x minus 4 equals 4. And then we say 4 or x minus 4 equals negative 4. So you set up 2 equals equations as it can equal both, just like we said x is equal to plus or minus 7. So whatever is in here, as long as we get out of 4 or negative 4, that will equal 4. So x will equal what? 8, or x will equal 0. When you go to graph, this is not acceptable, right? What am I missing? Dots. You got to put a dot and put a dot, okay? So number 2 here is when we have something like this, absolute value, let's go with 7, 5 minus 3z is less than, pick an easy value. 21. Yeah, we'll pick some easy non-fractional values. Okay, so the first thing we need to do is you look at it, what's the first thing we need to do? Very similar to number 1.
Isolate.
Isolate the absolute value by doing what? Divide by 7. So we get absolute value of 5 minus 3z is less than 3. At this point, the issue is that we struggle to remember flexure minus. Thank you. Sorry. Does sorry cut it?
No.
No. A change of action does. So here we go. If we have absolute value less than, what we know is that x was less than 6, greater than what? Negative 6. So if it's a less than, we turn this into an end statement. You leave this and this the exact same. So 5 minus 3z is less than 3. Don't change that. And what? Greater than? Negative 3. So you change that to a negative and make it a greater than. Just follow that rule every time. So there's really kind of just 3 rules you need to remember. And then we solve it out. We subtract the 5, subtract the 5, subtract the 5. We get negative 8 less than negative 3z less than negative 2. We divide everything by 3. What does that give us? I'm sorry, divide everything by negative 3. 8 thirds, good.
Oh, greater than.
Why does it switch it?
Negative.
Divided by a negative, right? So then we have z is greater than 2/3 and less than 8/3 for the correct formatting. And then it's a 2/3 open circle and 8/3 open circle. Whoops, sloppy, and a
Rainbow!
Double, double rainbow!
Okay, that was good.
That felt solid. It felt
What
strong.
instrument?
Oh, you know, you should do like a little introduction to the rainbow thing with the trumpet or the trombone.
Okay. And
So if it's an and statement, it turns out to be a rainbow, and if it's an
almost
single,
always, not always, but almost always, yeah. So, yeah.
and then it's just an or just like regular thing, it becomes that.
Yeah. Okay, so here we look at it, we gotta isolate. What's our first step to isolating?
6 plus
6 plus 5.
Amen.
Wait, subtract 6.
Subtract
Subtract 6. So we get 5 absolute value 2r minus 3 absolute value greater than or equal to
2.
negative 2. Okay?
That's what I said.
Yeah, and then divide both sides by
5.
5. So you get a negative 2/5. So then you say, okay, this is absolute value. It is a greater than, therefore it's going to be an or, right? So you leave it the same. You say 2r minus 3 is greater than or equal to what? Negative 2/5. Or
Less than.
2r minus 3, you change this and you change this. Less than or equal to what? 2/5. Right? So it's leave everything the same. This, and this. And then or leave this, but then change this sign and this sign to 2r minus 3 less than negative 2/5. Add the 3 over. Come on, do some math with me. Don't sit there and stare. You got a calculator if you need to. What's 3 minus 2/5 give you?
236. Which is 13.
2 and 3/5. 13/5. Divide that by 2, or multiply by a half. We'll call that 13/5. What do you get? R is greater than what? 13/10. Okay? Then you do the same thing over here, but this turns out to be 2r is less than or equal to, add 3 over. 3 and 2/5 is 3 and 2/5, which is 17/5. That's a 2r, not an r. Okay? And then multiply by 1/2 to get rid of the 2. R is less than or equal to 17/10. So then we got to graph this. That's equal to and equal to. We'll do that. Okay. So 13/10 is the same thing as 1.3. That'd be fine to go like that. 17/10 is 1.7, and it's greater than that. Close. Greater, less than this. Close. And what does it form?
Or
Everything.
A bird with its wings.
all separated.
Crisscross.
Crisscross applesauce. Yeah, there you go. Why does it crisscross applesauce?
It's equal to or greater.
It's an or. It's an or. How many statements have to be true in an or? At least one. So 1.3, everything to the right works. 1.7, everything to the left works. Now, therefore, what's our answer?
Every day.
All reals. Okay, so there's your graph of your answer. Now, here's the deal. What you could have recognized is right here. Absolute value greater than a negative. Absolute value always makes something what?
Positive.
Positive. So no matter what you plug in here, what are you going to get back out? A positive. Well, positive always be greater than a negative. Yeah, therefore you could have recognized right there all reals. And I would say yes, you could justify that statement.
How did we find out this was an or problem?
Because it's greater than or equal to.
When the variable
So we
is
track
greater
back over here to the easy one where it's just x and it's just 10, and we kind of logically think through what are the values greater than 10? Sure, 11, 12, 27.2, those all work, but are there other values that work? Sure, negative 11 does, because negative 11 is 11 with absolute value. So then recognize, well, all the values from here going this way work, therefore it's what type of statement? It's an or. Which I did right here. I should have, I'm sorry. Next is less than negative 10. So if it is a greater than, it is an or. If it is a less than, it is an and. Make sense? So isolate, then determine and or, and then solve. And remember, if it's an and, okay, or an or, you keep the original the same. This, and this all stay the same, and then you flip the sign where this turns, like if this is less than, it goes greater than, and then this was a positive 3, it turns into a negative 3. Here, you keep, even though we recognize later it's all reals, but this is greater than this, so you keep that whole thing, right? This, and this all stay the same right there. Since it's a greater than, it's an or, you keep this, and then change this, and change the sign to be less than and 2/5. So you just follow that rule. The only reason why it's hard is people don't know how to follow a rule. Understanding this, I would say most people understand this, You're like, oh yeah, that makes sense, but as soon as you translate it to a 2r minus 3 greater than, all of a sudden it's like my understanding's out the window. But you can follow the pattern, the algorithm, and say, I'm just going to plug into the pattern. And then solve it, and you got it. But many people on the test, although there's only 8 of you, so that becomes less, only many, a few, they just do that portion right there and solve. And you'll lose all 4 points, because I'm not testing that you can do this less than that. That was 2.2. I'm testing to see if you can take this information and turn it into the whole thing there, rather than just this little component. Okay? All right, let's go ahead and work on the homework. We have 1 to 27 on. If you, 10, 14, 26. If you can't get this done, we did burn a decent amount of your time chatting about other things. We can make this due on Wednesday with your test if you want.
That's a great idea.
You Wednesday, graded Thursday?
Yeah. So, but this will be on the test.